So back to page 89 so we can finish up our parent functions. We're going to have tangent. So f of x is equal to the tangent of x. So let's fill in some stuff that we know about tangent. What is the tangent of 0? 0. Tangent of 0 is 0. What is the tangent of 2 pi? 0, because we're back at 0, right? What is the tangent of pi? 0, okay? And then, so let's go halfway. What's the tangent of pi halves? Undefined. And so how do we normally show undefined on a graph? Vertical what? Asymptote. Very good. So since tangent is undefined at pi halves, we're going to have a vertical asymptote right there. Make sense? What's the tangent of 3 pi halves? Undefined also, so we're going to have a vertical asymptote there as well. Okay, make sense so far? Okay, so that's kind of not enough, right? So those are the 5 things that we did for, or the 5 x values we used for sine and cosine to graph it. So let's try another. Let's see, pi fourths. What's the sine of pi fourths? Not the sine. What's the tangent of pi fourths? 1. So I have a point here at 1. Then this will be 3 pi fourths. What's the tangent of 3 pi fourths? -1, because 3 pi fourths is in the second quadrant, yes. So that's pi fourths, 3 pi fourths. This will be 5 pi fourths. What's the tangent of 5 pi fourths? 1, because that puts me in the third quadrant, and tangent's positive there. And then I have 7 pi fourths. What's the tangent of 7 pi fourths? -1, because then I'm in the fourth quadrant. Okay? We good with that? All right, so do you kind of get an idea of what this graph might look like? Here, these 3 points, I mean, they're in a line, but I know that I can't draw a line through them because I cannot cross a vertical asymptote. I can cross a horizontal asymptote. You cannot cross a vertical asymptote. So the idea of the asymptote is that we get really, really close, but we don't actually touch it. And I have to go through these points, and then same thing over here. So this shape in here looks very much like a cubic. It's not a cubic, because a cubic has a domain of all real numbers. It keeps going, but it has that point of inflection in there. So your graph will look something like this. And then it repeats, right? So this part looks like this. This part looks like this. We'll repeat everything in just a second. But all right, so there's 2 pi. 2 pi units we went through. We good? Can we repeat for the rest of it? Yes? Okay, so let's repeat for the rest of it. That means that I'm going to go negative pi fourths will be at -1, right? Negative pi halves, I'll have an asymptote. That is not a pi halves. Negative pi halves, I have an asymptote. And negative 3 pi halves, I have an asymptote. Okay. And that'll help me get the rest of it in there. Point here, here. Oh, and one here. Come on. This point here. So very different than sine and cosine, right? It's still a periodic function because it's repeating, but it doesn't oscillate like sine and cosine do. And I cannot write the equation of this in the form of sine like I could with cosine. All right, other than looking completely different than sine and cosine, another difference is the period. What's the period here? How long before we repeat? Pi, yeah? And so it's easy to look between the two asymptotes, right? So from pi halves to 3 pi halves, that's pi units, and then everything keeps repeating. For consistency purposes for graphing, I still like to start at 0, which makes the parent function little sketch look a little bit weird. But you can see if we start at 0, come up here, asymptote, and then when I get to here, I get to pi, then it starts repeating. So for the parent function, what we'll sketch will look something like this. You're going to go up and down, and then we have the asymptote there. So instead of having 5 anchor points, we have 5 anchor pieces, I guess you could call them. We have the beginning and the end. The middle is the asymptote, so that's still a piece we want to get in there. And then we'll have these 2 points here. So really 4 points in an asymptote instead of 5 points. So there's still 5 pieces there. Everybody good so far? All right, what is the domain? Is the domain all real numbers? No, because there's lots of x's we can't use, right? I have all of these, but then boom, I don't get to use pi halves. I don't get to use 3 pi halves. So everywhere there's an asymptote, that's not part of my domain. The asymptotes happen every how often? Every pi units, right? And they start at pi halves. So my domain is going to look something like this. It's the set of all x's such that x cannot equal. They happen every pi, so that's where my n times pi comes from. But I start at pi halves, so plus pi halves, where n is an element of the integers. And remember, I'm not going to ask you to recreate that. I do expect you to understand why we have to write it like that and what it means. But because I want you to see the notation, especially if you take upper level math or science, you'll see a lot of weird stuff like that, and just understand why we have to put that. So are we all good? Okay. What is the range here? All real numbers, so we got negative infinity to infinity. Zeros, how many zeros do I have? An infinite amount. So just like with sine and cosine, I had an infinite amount of zeros, right? So it's going to have to look something like this. So the set of all x's such that x does equal, okay, so this is what we're eliminating from our domain. Here we're saying this is what it is. And they happen every how often? Every pi. So it's n times pi, and then since 0 is one of them, I don't have to add anything to it, where n is an element of the integers. What's my y-intercept? 0, 0. Sorry, it jumps. Okay. Asymptote. Well, yes, I have them, right? And remember, your asymptote and your domain, they're very much related, just like when we did rationals. Because the reason that you can't have these x values is because you have asymptotes there. So it's almost writing the identical thing. Here we're saying x cannot be these numbers. Here we're saying our asymptotes are these lines because it's an equation of a line. So it's not a set of x's. It's an x equals line. X equals, but there is an infinite amount of them. So my x is equal to n times pi, where n is an element of the integers. Okay? So again, it's a set of x's here. So that, because those are the ones I eliminate from the domain, this is basically a set of lines, not x values, so that's the equation of my line. Okay, we okay with that? Amplitude, all right, so my amplitude is half the distance between the max and the min points. What's the maximum value for my tangent function? Infinity. Is infinity actually a value? No, okay? So since it's not actually a value, because we do go to infinity, then I don't actually have a maximum. Does that make sense? Because the maximum value has to be a number. The value is 10, the value is 20. When we go all the way to infinity, we can't reach that. Once we reach it, we can still go farther because it just keeps on going. So basically my amplitude does not exist. There isn't one. If I can't find the max and the min, I can't take half of it, right? What's the period here? Pi. And that's the biggest thing you got to make sure that you focus on. that the period is pi, because that's a change from sine and cosine, and the way we calculate everything is going to change a little bit. It's not more difficult or anything, you just have to remember that they're different. Okay? Any questions at this point? All right. Then let's look at the transformations. So transformations will look like this. F of x is equal to a times the tangent of b. Oh, that is not what I'm trying to write there. B times x minus c plus d. Notice that this says a and not amplitude where it did for sine and cosine. If you receive anything from me where you are graphing tangent and it says amplitude, it's not a trick question, just mark it out and put A. I'm probably a victim of copying and pasting, and I think I caught everything, but I'm pretty sure that the paper that you're going to pick up on Monday that you're going to work on says amplitude even for the tangent ones. Just mark it out and put A. I mean, obviously, we're working with the same stuff there, right? It's just that it's not technically called the amplitude. We're back to not having a name. Okay, let's see. Emily's not here. Holly is here. Caden is here. Daniel. Goodness gracious. Okay. He is not here. I don't have those people. Sorry, that's the wrong one. Okay, I'll give these out. Thank you. Okay, I'll give these to you at the end. All right, so the A, it still does the exact same thing even that the amplitude did. It's actually the absolute value of A, and it is your vertical stretch or compression. We're going to use, like when we do these little points, for the parent function, this point's at 1. So we're still using 1 like we did for sine and cosine. So we're still kind of doing the same thing. We just don't call it amplitude. All right, so the period. The period, remember, it's still just 1 cycle. So the period is equal to, what's the period of the parent function? Pi. So this is pi divided by the absolute value of b. So you're finding it the same way by dividing by the frequency, but you're using pi instead of 2 pi. You need to remind yourself of that when you're doing tangent, because that's one of the biggest mistakes that I see, is that you're just using 2 pi because you've been doing that for sine and cosine. Frequency is the absolute value of b. But to find it, it would be pi divided by the period. Okay. Horizontal, our phase shift is still C. Vertical shift is still D. Midline is still Y equals D. What questions you got? We good? All right. So grab that other piece of paper. Remind myself what page we're on, 94. Okay. Oh, yeah. It's going on page 94 when we're done. Okay. So our parent function that we're going to sketch looks like this. And remember, we're using, these are still our midline zeros, and then for the parent function, this is at 1, this is at -1, and we just adjust accordingly with our transformations. So, tangent function, undefined for certain values, that's why we have vertical asymptotes. The tangent function does not have an amplitude. This is here to sketch the parent function, but we just did that on that other paper, so we're just going to let this be what it is. All right, so here's some transformations. So remember that the period for the parent function is pi. From an equation, it's pi divided by the absolute value of b. I'm going to give you how you can calculate where the asymptotes are. We're not going to do it that way because we're really just concerned with graphing, but I want you to know that there is a way to do it. It is the odd multiples of pi divided by 2 times the absolute value of b. That's just an FYI. Don't go back and try to use that for anything. Okay. All right, let's work through some graphs together here. All right, so in number 1, what is A? Try again, 4. Okay, I wish I had put frequency first, but I didn't. I put period first, but we're still going to talk about frequency first. What's the frequency? 1. The frequency is 1 because B is 1, which means what is the period? Pi. Do I have a phase shift? No, so that's 0, and my midline is y equals 0. My parent function looks like this, so I can follow along. All right, so I'm going to put in my midline right there. Same type of pattern as before. We start at 0, 0. Okay, so that points at 0, 0, which means it's the midline 0, 0. That only changes if we move left or right. We're not moving left or right, so I have a midline 0 right there. The end of the period is at pi. That's also a midline 0, so I'm right here. So we did the beginning, we did the end. Now we do the middle. Middle is an asymptote. So halfway between these two, there's my asymptote. Then halfway between these two, I go up, whatever the amplitude, whatever A is, not an amplitude. Halfway between these two, I'm going to go up to 4. Halfway between these two, I go down 4. Okay, there are my 5 anchor pieces. Any questions on where anything came from? All right. Now just repeat the pattern and get the rest of it in there. All right, any questions about that? All good? All right, on number 2, what is A? 1. What is the frequency? 1/2. So then what is the period? 2 pi. Good. Do I have a phase shift? No. And my midline is at y equals 0. Okay. So here's my parent function. Here's my midline. All right, so this is a midline 0, 0, as long as I don't have a phase shift, and I don't, so I got a midline 0, 0 right there. End of the period is at 2 pi. 2 pi. Halfway between the two, I have an asymptote. So that would be at pi. Now, A is 1, But I do have this negative here, which means I do what? Reflect. So halfway between these two, I would go up 1, but instead, since it's a reflection, I go down 1. Then halfway between these two, on the parent function, I would go down, but there's a reflection, so I go up 1, and I'm right there. Any questions about the points? All righty. So then repeat and get the rest of it in there. Oh my gosh. I've hit the points. There we go. Remember, you have a point of inflection, so point of inflection is where it changes from being concave up to concave down. Like so. Any questions about any of that? We're good? Awesome. All right, let's look at number 3. What is A in number 3? Or actually, I have parentheses here. Do I need to factor? No, I don't need to factor. Okay. So what is A? 1. What is the frequency? 1. So that means the period is pi. Okay. Phase shift, I do have 1. What am I doing here? Left pi fourths, midline, y equals -3. There we go. So I get in my midline here. We good? So I start with a midline 0, 0. But I have a phase shift, so I'm going to put my pencil there. But then I'm going to move to the left pi fourths, and that's where I go. Okay? The end of the period is at pi on the midline, so I put my pencil there, but then I move to the left pi fourths, and I got that. So I have the beginning, I have the end, go halfway between the two to get my asymptote, which is right here. All right, so no reflection, and A is 1, so halfway between that first point and the asymptote, I go up 1, and halfway between these two, I go down 1. Okay, we good? And then just lather, rinse, repeat. And make sure when you draw it in that you're actually hitting the points, unlike I am. My hand's in the way. That you're actually making it like the length of the graph, because the idea is that it's hugging that asymptote, right? Okay. Any questions on number 3? Good. All right, let's look at number 2. Do I need to factor, number 4. Do I need to factor in number 4? Yes, I do. So this is going to become f of x is equal to 2 times, no, I don't need parentheses here, tangent of 1/2 times x plus what? Pi, good. Let's close, plus 1. All right, so now that I've done that, then I can do the rest. What is a here? 2. What is the frequency? 1/2, which means the period is 2 pi, right? Because I have to divide by 1/2. Phase shift, I go left pi, midline, y equals 1. All right, y'all get that one graphed. Alrighty. Check yourself with me when you're done. If you're still sketching, that's fine. Check yourself. And then hand it out the worksheet, and you have time to get those graphs taken care of today. We good? Any questions right now? Awesome.